oh boy, word problems, woohoo! Okay, look at this question. It looks awful, but it says, determine a fully factored expression that represents the shaded region of the given diagram. Well, if you look at this, this looks like some sort of donut with an offset hole. I know what you're thinking. Donuts. No, sorry. I lost my train of thought there because of donuts. But it's very simple. If you're wanting to find the shaded region, find the whole region and subtract the whole. I think that's pretty straightforward. Knowing that this is a circle, you know that it's a pi r squared kind of a problem. So it's a pi r squared of large area, subtract the pi r squared of the small area, or what we like to call the donut hole, okay? To find how much of the donut you're going to actually eat. All right, so here we go. Let's do it. Pi, that's easy. The radius of the large one is, that's 5y, so that's 5y squared. Subtract the small hole, which is, again, pi, because it's a circle. Subtract 2x squared. Now, here's where most students mess up, and let's just take a half a second to make sure that we understand this. Remember, this is a squared, which remember means everything inside the bracket is squared. So this, in fact, is pi. That is now 25, and that is y squared. Subtract, same thing goes with this. Pi, that has to be squared, which is 4, and that has to be squared, which is x squared. Now, this looks awful, but if you remember what I told you to look for every single time in almost every podcast, I told you to look for the GCF. If you GCF this, you can take out a pi. Aha! Leaving you with 25 y squared minus 4x squared, and oh my goodness, it's now a difference of squares. Look how beautiful this question works out to be. Take the pi, put it up front. You know it's going to be two factors. You know it's going to be the square root of this guy, which is 5y and 5y. You know it's going to be the square root of this one, which is 2x and 2x. And you know one's going to be plus, one's going to be minus. And look at that. That is your whole factored form of the donut question. What a great question. I'm going to Timmy's.